Ben Pearson, the Research Tracker. Today I'd like to talk to you guys about my favorite image from the James Webb Space Telescope that's been released so far. And it's really because when I looked at it first, I didn't really understand how it could be real. But as I started to understand it more and more, then it's a really pretty neat series of events that leads to it. And that is the image of WR140. Now, the WR stands for Wolf-Rayet, which is a type of star that we'll explain a little bit more about later. The thing that initially caught my attention that really excited me is these rings look like diffraction rings. They look like there's some kind of a mistake with the telescope, but they're not, and you can tell for a couple of reasons. First of all, they're not actually perfect rings. You can see in a couple of spots that they bend a little bit, and secondly, they don't go all the way around, and a diffraction ring would do that. So this isn't an artifact that's James Webb Space Telescope. The only artifacts there from the telescope are the various pokey things that go out from every side to side. That is a result of the hexagon shape and the mirror supporting scaffolding that happens. It's unfortunate, but it's pretty cool. While we see this in other telescopes, we don't see the depth that we see in James Webb. James Webb has a really, really good ability to see both the bright and the dim. And so as a result, we're able to see many more of the rings than we have been with other telescopes, which is pretty cool. So as previously mentioned, this is a Wolf-Rayet star. It's actually a binary star, although the one that has the more significant signature is the Wolf-Rayet. The other one may be putting out more light, but it's really hard. So when astronomers look at stars like this and they want to figure out what they're made out of, they can take the spectrogram. And the spectrogram of it, you basically take the light, split it like a prism, and you can look at it. And there are certain elements that tend to absorb certain of these lines. And so those lines will not be present when you're looking at it that carefully. So what we find with Wolf-Rayet stars, and these have been known for some time, is that they have a much higher amount of helium, nitrogen, oxygen, silicon, and carbon than a typical star. But most notably, they have much less hydrogen. And so there's been a lot of debate as to exactly how these form, but they kind of seem like a star on the end of its life. They can be very hard to observe because we often see them in dust clouds, or they have some companion that can obscure the signature that can make it really hard for us to really know what's going on, but they're quite interesting. WR140 is a tie for the second brightest Wolf-Rayet star in the northern hemisphere. This star is a binary, although, as previously mentioned, the Wolf-Rayet star dominates the spectrum. It's likely a giant or maybe even a supergiant star, which means it's very large and probably towards the end of its life. Technically, this is a variable star, although the variance is pretty subtle. What happens is these two stars orbit each other every 8 years. And when they get close to each other, and this will start to explain the mystery of what's happening, then they kick off a large amount of dust, and so it will increase in its brightness for a couple of months and then start to dim again. And so what's happening with this, and there's a nice illustration that was released by the James Webb team, is you have the star coming close to the bigger star. So you have a companion star that's in a highly elliptic orbit. It's coming out, comes close to the bigger star, it kicks up a whole bunch of dust, and we see these rings that form around it, and they'll spread out slowly over time so that by the time that the next one passes, then we create a new ring. And you only tend to see it on half of the star because it's really the half of the star that gets a close approach, and thus it's kind of very unique characteristic shape. It's kind of a nice little story that comes with this picture, and there are many others out there. James Webb is an amazing instrument, but this one caught my attention because of my interest in photography and the fact that it looked like diffraction rings, but I knew it wasn't, so I was very curious to figure out what it was. Anyways, thank you guys much for joining me. Let me know what your favorite James Webb Space Telescope image is. Thank you to my Patreons and subscribers, and those who like, and those who just watch the video to the end to hear me rambling about all this stuff. You guys are amazing. Thanks for everything. Until next time, keep on tracking. Take care, guys.